in this video I'm essentially going to go over every single maths module you'll learn in the first semester of your maths degree. Now in this case it's going to be financial maths because I do financial maths. However, it only differs by one module in the first semester. I'll get onto that in a bit. Now the way the first semester works in your first year of uni is you have the most contact hours then. So I had about, I think it's about 20 to 21 hours worth of contact time, so that's built up of lectures, tutorials and personal tutor or personal meetings by your personal tutor. And the way the term works is you'll learn these modules all the way from September until the very end of December in your Christmas break, and you'll be examined on these in about the third week of January. So let's get into the first module. First module is Foundations of Mathematics 1. And you can see there's 94 pages in this document. Now that is every lecture in this module. So you're pretty much given all the notes on the very first day. So you can basically decide not to go to the lectures and just read them in your own time, go through them in your own time, which is what people say they'll go to the lectures, but they pretty much don't, especially if you've been out the night before. Here we've got sort of starting off with A-level material, and then we move to complex numbers, which again A-level material, and then we sort of differ away from that, which is logic sets, formal logic sets, equivalent relationships, then we've got groups, cosets within the groups, what else we've got, inequalities and suprema, sequences, series, and then the real numbers. So this is, if you want to just click onto any random page. So this is binary representation of real numbers. So this is an important module for you to sort of get into the university style of maths learning. And then every week you'll read through the notes, and then you'll have a problem sheet relating to those. So this was the very first problem sheet that I had in uni. So this is proof by induction, which you would have done at A level. What else we've got? Yeah, proof by induction here, proof by induction there, and then you've got some complex numbers, really sort of basic stuff, getting you into the A level, also the university syllabus. And you've got also supplementary questions. This will essentially just sort of test your knowledge further. And then these will be, you'll have a pigeonhole in your sort of maths office school. You put these in, a week later they get marked, and then you go back and check them. The next module I had to sit was Linear Algebra 1. By the way, these are all compulsory. I didn't get any sort of choice in my first, I don't think I got any choice my first year, no I didn't. This is Linear Algebra 1. This module is quite sort of, it's quite different in that it's very obvious stuff. So for example, you have to prove that 0 plus 0 equals 0, and also k times 0 equals 0. So it's very sort of, it's very intuitive stuff, but you really have to prove it in order to sort of explore the maths. So let's have a look what we've got here. So vectors in 3D space. What else do we have? Matrices. This will start building on your matrix knowledge. So obviously commutative here, a plus b. K times a, so obviously that's just equal to the k plus the index element of a11. So if we go down, I think there's some, could be a bit slow. So yeah, this is a classic problem, proving something is a vector space, proving something isn't a vector space. So if it's closed under addition and also under scalar multiplication, then it's essentially a vector space, but you'll learn this in your degree. So here we go. These are sort of properties of vector spaces, and then in your exam you will have to prove some of these. So where are they? So k times 0 is the 0 or 0 element. So if u is contained within v and k is contained within or is a real number, satisfies k times u equals 0, then k also equals so k equals 0. Can't speak. K equals 0 or u equals 0. Now if you think about that, it looks a bit complicated, but essentially that's saying that if this is true, then or for this to be true, either k has to equal 0 or u has to equal 0, or again, or they both can be equal 0. So if k is 1, then for this to hold, u has to equal 0, or if inversely is u is 1, then k has to equal 0, or again, can both be 0. Minus 1 times u is equal to minus u. And so this module is all about sort of concrete evidence of showing that in order to build on linear algebra knowledge. And again, you'll have problem sheets of this, so let's have a quick look through the problem sheets. This was the very first problem sheet I had for linear algebra. So if you're doing A-level stuff here, you'll know this straight away. So look, Given a matrices, what's A14? That's obviously just 2. A22, which is just 4, and so on and so forth. But I guarantee it does get a lot more complicated than this. This is the very first problem sheet, so it's just sort of bridging that gap from, again, like I said, A level to university. Now, the third module I sat was the first finance module I sat, or first sort of finance related. No, not that one, sorry. It's this one. So this is called Economics for Financial Mathematics. So as you can see, this is the content. So we've got demand and supply, utility theory, profit, cost and production, market competition, GDP, and so on and so forth. Now, you'll notice Unit 8 is a self-study. This means that there was no lectures on this module and you had to learn it yourself. This is quite common in university. They'll essentially show you the materials for it and you have to go away and learn it. If I had to go through, I think I picked GDP here. So yeah, this is essentially 50 lectures or 50 slides on GDP. So this would be about a week's worth of notes or lectures. So essentially it's showing you the components of GDP. I haven't been through this. The income approach, national income. Yeah, so you've got to obviously know this for the exam. Now the second module I sat was something called Introduction to Probability. However, the lecturers actually deleted these from the sort of website, so I had to download. Luckily, I downloaded them myself previously to this. So this is, like I said, Introduction to Probability Theory. So this is the very first lecture. So this is set relationships. This is a set theory. So we've got sample spaces. Sample space is essentially the outcome of everything that can happen. So if it's a toss in the coin, it's heads tails. If it's one coin toss or tails heads. So there you go. Rolling a die. So it's 1 through to 6. We'll go through the relationships, the set differences, the properties, which will again have to prove them. Venn diagrams, which seem very sort of GCSE level stuff, but I think graphs are always a good way to learn maths anyway, particularly for me. Definitions, family of events, field of events. So that's set theory. That would be 1 week's worth of stuff, and then we'll move on to probability, which is sort of probability measure, your examples, which would have been done in a lecture. So you'll notice if you just read the notes, sort of. So that's the point I was going to make. If some lectures, what they do is they essentially leave spaces blank, so you have to turn up to lectures. Some of them are recorded, some of them aren't, but the recordings aren't always great. Imagine maybe getting into next year when sort of it's more in person and you've got the online facilities, then it probably will be a bit better. You've got a proposition here, so prove that the empty set of 0 or equals to 0. You've got a proof for that for any event. So yeah, so this again is within A-level syllabus. However, I would say probability and stats do quite quickly get out of the A-level material and quite complex quite quickly. So you've got a partition theorem here. Yeah, stuff like that. Now there was a final module for this semester, however it's called University for Skills and Beyond. Essentially this was a research project that it didn't involve any maths, but it involved a research element to it. You essentially had to go away and find out a bit of maths that you found interesting and talk about it essentially, or make a video on it, it was worth 10 credits, so it was worth doing, but it's quite a boring module. So if you enjoyed this video, be sure to like it, and I'll also be doing a second semester one, and also any other sort of university stuff that you'd want to know. And if you've got any comments, leave them below and I'll be sure to get back to you. Thank you.